Carly.
Hey, Wade. Today, we're going to talk about conditional probability. And I think we're going to dive right into it with an example that you can share with us.
Yeah, so my favorite celebrity in the world is Taylor Swift.
Love her.
And I have some awesome medical data that we just got about 200 people who got tested to see whether or not they were related to Taylor Swift.
Ooh.
And they all got their results back, and they all have either a positive test result or a negative test result. And I think you were talking to the lab. What does the lab say?
Yeah, are you ready for it? So here goes nothing. They said that of these 200 people, I guess of all people, only 1% are actually related to Taylor. So sad day. That's a small percentage. So 1% are actually related. And then they also told us 1% are actually related and that this test is pretty good. Like all medical or genetic tests, they're not 100% accurate, but this is actually 99% accurate because they said if you are actually related to Taylor Swift, so there's a 99% chance that if you are related, you will get a positive result. You will correctly get a positive result. 99% chance that if you are related, you will get a positive result.
But there's a corollary to that. And that is that there's a 6% chance that if you're not related, that you're also going to get a positive result. So there's basically two different ways to get a positive result. You can get a true positive, which happens 99% of the time if you are related, or a false positive if you 6% of the time if you're not related, even though you still get a positive result. So because this test is really quite good, I'm suspecting that if I get a positive result, I'm almost certainly related to Taylor.
So that's what we're going to go ahead and find out. What is the question from this data is that if Wade comes and tells me that he got a positive result, what's the chance he's actually related to Taylor? So how would I write that in terms of a probability?
So when we have probabilities, we've normally just written an event inside the probability.
Right, and we've looked at the probability of an event and another event occurring, an event or another occurring. But here we're actually looking at something called a conditional, which is basically what's the probability of an event given that another event occurred. So here we want to know for Wade, let's just say, did you get a positive result?
I did.
Oh, good. All right. So we want to say that given Wade got this positive result, what's the chance he's actually related to Taylor? And like I said, there's some notation for this given notation. We can say that the probability of A given, which is represented by a straight line, B is read like that. So here I want to know what's the probability that Wade is related to Taylor, given that he got this positive result. And you said you think that's pretty high?
99% of people who are related to Taylor Swift get a positive result.
99% of people who are related do get a true positive.
That's me.
So there's a couple different ways that we can solve this problem. And I'm going to talk about my favorite way first. And then we'll see Wade's favorite way later in this series. But my favorite way is to actually go ahead and make a contingency table. So we have two conditions here. Our first condition is whether or not you're related, right? So I'm going to say related to Taylor Swift and not related is our first condition. And then I'm also going to say we got a positive result and a negative result. So I'll also put the totals here since we are looking at probability. It kind of makes sense to think about the totals as well. So I'll put that on both the rows and the columns. And we can fill out this table with this given information. So this was given to find out our new probability. What's the probability that Wade is related given he got this positive test result? And he's hoping it's pretty high. So let's start off. It's always good to fill out one of the total column first. We always want to start off with, in this case, it makes sense to do what's the 1% are actually related to Taylor Swift. So we know we have 200 people, you said, who took this test.
That's the data we have.
Perfect. And 1% are actually related. So I'm going to go to this related column and say of these of these 200 people, 1%, which is represented by 0.01, not to be confused with 10%, which is 0.1. And I can just say 1% of or 1% times 200. And what do I get, Wade?
So 1% of 200 is exactly 2 people.
Exactly 2 people. So only 2 people are actually related to Taylor Swift out of these 200. The question is, what's the probability? Wade is one of them. And so then now I can use the rest of my information to fill out the rest of the table.
So before you do that, would you fill out this blank since you always have to make sure you add across?
Yeah, so with these tables, that's great. Let's do that first. So if I know 2 people are related to Taylor Swift, that means the rest of them are not, right? So how many is that?
198 remaining.
198 remaining.
But I'm one of those 2.
But hopefully, yes. Okay, so it says we have, this test has a 99% chance of getting a true positive. So basically, if you are related to Taylor, there's a 99% chance you'll get a true positive. There's only a 0.01% chance that you'll get an incorrect negative. So there's going to be some fractions here, but let's just, for the sake of this problem, when we're dealing with people, let's just round to the nearest whole number. It's not going to change the probability a lot. It's still going to be pretty accurate. So 99% of 2, I'm actually going to round that and just say, if you get that positive result, you're probably related to her, right? And then this would be, it's going to be small, but I'm just going to round it to about 0. What about the, oops, I just realized that I wrote true positive here, but this is actually a false positive. I didn't either. This is a false positive. So I am going to use this. There's a 6% chance. So if you're not related, there's still a 6% chance that you'll get this positive result. So 6% is 0.06 times 198. And Wade, what do I get rounding that to the nearest whole number?
So that's going to be rounded to 12.
Perfect. So 12 people, that's kind of a lot, will get a false positive. 12 versus 2. Ooh, I hope that's not you. And then what would I have? So if 12 of the not related people get this false positive, the rest of them are going to get the true negative. So what would that be?
So 198 minus 12 is 186.
186. So remember, a nice property of these tables is that you do the rows and columns always sum. So if I want to find these totals, total number of positive results is 14, and then the total number of negative results is 186. And you can check yourself, 14 plus 186 does indeed add to 200. So now that I took the time to fill out this table, I can answer any probability question easily just by looking at it. So that's why I like making the tables, because you can use your given information to create it. And then after that, smooth sailing. You can answer anything you want. So back to our question, it said, what's the probability that Wade is related to Taylor Swift, given that he got this positive result, right? This means given. So I'm only caring about, I know he is one of these 14 people, given we got a positive result. But if I look, his chances aren't super high. The chance that he's related is just 2 out of, there were 14 total positive results, and most of them weren't related.
So sad.
Yeah. So this is about, what is this? If we want to think about this as a percentage, 2 out of 14 or 1 out of 7.
1 out of 7, that's what, like 14.5%?
I was going to say around 14%, which, sorry, Wade, but not looking great for you.
Oh. So this means that positive test results really not that useful.
At least in this case, because, and the reason that that's the case is because this is a rare event. Being related to Taylor Swift, you only had a 1% chance to begin with. So because there are some false positives, even though it's not super high, there's going to be more false positives than true positives. So if the event that we were looking at, like what if there was like a higher percent, like even if there was a 50% chance that we were related to Taylor Swift, your probability would have been higher. So this is one way that we can use tables to solve conditional probability problems. And I'm sorry, Wade, but you're probably a false positive. I know that's not what you want to hear.
I'm still holding out on my 14% hope.
There is a chance, 14%.